Hello, and welcome to the lesson on two-column geometric proofs. I'm not going to lie, proofs are what everyone hates about geometry, but we're going to try and make it as fun as possible, and I will for sure help you out. It takes practice, okay? So we're going to complete two-column proofs to prove theorems about segments and angles today. All right, so earlier we talked about two-column proofs when we were solving algebraic equations. We justified each statement using an algebraic property. So we had subtraction property of equality, addition property of equality, etc. But now we're going to use two-column proofs to prove geometric theorems. So you must justify a statement by using a definition, a postulate, a property, or a previously proven theorem. So definitions we've come across, definition of a bisector, postulates we've seen, segment addition postulate, angle addition postulate, properties, transitive property, etc. All right, so recall that vertical angles are opposite angles formed by a pair of intersecting lines. So in the figure below, 1 and 2 are vertical angles. Okay, they're opposite of each other. They kind of get that V going on. The following example illustrates how to prove that vertical angles are congruent. So you guys have just trusted me in the past when I told you vertical angles were congruent, but here is actually why they are congruent to each other. So let's look at a proof. To prove the theorem that vertical angles are congruent, and this is called the vertical angles theorem, and it states that vertical angles are congruent. All right, so given that 1 and 2 are vertical angles, okay, we're going to prove that 1 is congruent to 2. So we're first going to start off with the measure of angle 1 plus the measure of angle 3 adds up to 180 degrees. Okay, that's kind of back to the first module. We've got a linear pair, we have a straight line, we know it's 180 degrees. Okay, so the reason that they equal up to 180 degrees is that's the definition of what supplementary means. Okay, number 2 says the measure of angle 2 plus the measure of angle 3 is also 180. So we also know that we've got a straight line going across, and that's another definition of supplementary angles. Okay, so that's using our knowledge of supplementary. Now, the tricky part was on number 3. So what they did is they were both equal to 180 degrees. Okay, so notice that, I'm going to try and color code this, all of this in red is on the left-hand side. Okay, and all of this in green is on the right-hand side. So basically, since they were equal to the same thing, they substituted this equation in for the 180 and got it on the right-hand side. Okay, so they substituted. You could probably argue transitive property here that all of this red is equal to the blue, and if the blue is equal to the green, then the red has to equal to the green. Okay, so they took this and substituted it in for 180. What happened from 3 to 4? So I'm going to color code this again. So notice 1 dropped down, 2 dropped down, and then all of a sudden this 3's disappeared. So to get rid of the angle 3's, they subtracted angle 3 from both sides. So that'd be subtraction property of equality. And then the only thing that happened from 4 to 5 is they got rid of the m, and that equal sign became a congruent sign. Okay, and that is something new that we've not learned. It's called definition of congruent angles. So what that says is if they're equal, then I know they're congruent. Okay, and so that is a proof for why vertical angles are actually congruent, other than they just looked it or you believed me. Okay, all right, so that is a theorem that we just proved, and so now we're able to say we know vertical angles are congruent. All right, so let's take a look at some proofs. Here's another example. All right, supply the missing statements and reasons. Theorem, all right angles are congruent. Okay, so we would assume that if they're right, they're going to be the same measurement, but let's prove it. Okay, so notice we had justifications in our previous lesson, but now they're going to be called statements and reasons at the top. So remember, statements are the mathy stuff, reasons are your words, definitions, etc. So what will always, always, always be true is there will always be a given to start you off. Now a given, they physically will give it to you, and it says angle A and angle B are right angles. So all you have to do is copy and paste the given to start off. So that is a nice, easy step. First thing is always given. Okay? Now, number 2. I know the measure of angle A has to be 90, and I know the measure of angle B has to be 90. So the reason I know they're 90-degree angles is that's the definition of a right angle. Okay? So if I know they're right, then I know they're 90. And that reasoning is definition of a right angle. Okay? Now I know the measure of angle A is going to equal the measure of angle B. So what they did there, I had 90 on both of these, similar to the previous one. If they're both equal to 90, they're going to be equal to each other, so I substituted that angle B in for that 90. And so that would be called the substitution property or the transitive property. It gets kind of confusing. You can argue literally both ways. So we'll go with transitive property for that. So if A is 90 and 90 is B, then A has to be B. Transitive property. All right, last but not least, from 3 to 4, they dropped the m's and the equal sign became a congruent sign. So this is going to be angle A is equal to angle B, and that will be the definition of congruent angles, going from an equal sign to a congruent sign. Okay? So hopefully proofs are they're hard, so it takes a little bit of practice to get through these, okay? So that was kind of a cut and paste proof, but now we're going to do a whole proof on your own. Ooh. So on A, it wants you to just list the reasons, which in my opinion I think is definitely easier. In part B, it wants you to list the statements, which in my opinion is harder because you're looking for some mathy stuff. All right. Notice in this bottom one, you can have two givens. That's totally fine. So you would copy and paste both your givens down there. But I want you guys to try these on your own. So press pause and give it your best guess, best educated guess, and then we'll go over them. Press pause. All right, so given part A, it says Q is the midpoint of PR. So boom, Q is the midpoint of PR. That is going to be a given. They gave it to us. So now, real quick, I'm going to do number 1, but notice I have another given. QR is congruent to RS, which is part 3. Okay, so the first thing that I do is I go ahead and mark all my givens. All right, so then I really only have to figure out 2 problems on my own. Okay, all right, but now for the thinking part. So based off this statement in number 1, Q is the midpoint of PR. That allowed me to say that PQ is going to be congruent to QR. So I'm able to make those congruent tick marks if Q is the midpoint. Okay, so now I have to ask myself, well, what was the reason? Why was I able to make these tick marks? Okay, the key word is probably going to come before it, midpoint, so I'm looking for a definition of a midpoint. Okay, so if Q is the midpoint, then I know both parts are congruent because that is the definition of what a midpoint does. Okay, now number 4 is pretty tricky. You have to look at the proof as a whole, so I can't take it as individual parts. So I first know that PQ is congruent to QR. I'm going to try and color code this. Then I know QR is congruent to RS. Therefore, PQ is congruent to RS. So the red was equal to green. The green was equal to blue. So the red is equal to blue. That is called the transitive property. Woo! Of congruence they put there. Okay? So the first part isn't too bad. Write down your givens. Early on in the proof, it's also not too bad as long as you know what midpoint means, bisector means, etc. Now, sometimes you're going to have to look at the proof as a whole, and that's where it gets kind of confusing. But again, it takes practice. All right. And the math tip is you can have more than one given. All right. Time for the harder part. All right, complete the proof. Angle 1 and angle 2 are supplementary, and the measure of angle 1 is 68. Prove the measure of angle 2 is 112. Okay? First off, I'm going to do my 2 givens. Boom, boom. The order does not matter. It's totally up to you. All right. So then based off number 1, 1 and 2 are supplementary. I need to write something based off of that. I know supplementary means 180, and it says definition of supplementary. So if 2 things are supplementary, I know angle 1, the measure of angle 1 plus the measure of angle 2 equals 180. If you forgot the m's, that's fine. They like to talk about them when adding. Okay. All right. Number 4 tells me I need to substitute. So here's an equation in number 2. I know the measure of angle 1 is 68. So what it wants you to do is substitute 68 into your equation. Okay, so replace the measure of 1 with 68, and then drop down, drop down. Okay, then it wants you to subtract, or, I forgot to tell you all this, the proof part is always going to go at the bottom, every single time. So let me go back up and prove that to you. Boom, that proof part was always at the bottom. It will always happen. Okay? All right. So here's an example of where you just write down the reasons and when you just write down the statements for a 2-column proof. Now we work our way up. We're going a little bit harder. Okay? If you're watching this, you don't have a table partner. All right. So example C. There is a typo in your notes, by the way. This should definitely say congruent angles. All right, example C. Arrange the statements and reasons below in logic order to complete the proof. If 2 angles are complementary to the same angle, then the 2 angles are congruent. So what they're trying to say is if A and B are both complementary to C, then A and B have to be the same thing. So that's very much kind of like if you've got McDonald's fries and a McDonald's burger that are both equal. Nope. I was trying to come up with an example and I flopped. I'll think about it. All right, but what I want you to do is put them in order. So for example, if you think this given goes first, you'll put a 1 next to it. If you think this goes next, put a 2 next to it. But put them in how you would get them in order. If you want to rewrite it too, totally fine. Press pause, reorder them, or rewrite them. Answers! So if you ordered them like this is the order you should have gotten. If you have the notes paper in front of you, maybe you realize the answer key was below. So I'm going to talk about the answer key below. All right. So again, first off, your given is always going to go first. When you're doing this, your proof part is always going to go last as well. So I was able to identify 1 and 5 just based off this proof part. Okay. So then, if number 1 is complementary, in part 2 you're going to have to talk about what complementary means, and we know that complementary means 90. So they said A plus C is 90 and B plus C is also 90, that being the definition of complementary angles. So then they use the transitive property here. Again, you can use the substitution property, but they said this, I'm going to color code it, this whole red side was on the right side, this whole green side was on the right side, whoops. And because they were both equal to 90, I could set them equal to each other, which is either the transitive property or the substitution property, however you think about it. What happened from 3 to 4? A dropped down, B dropped down, and then apparently C magically disappeared by the subtraction property of equality. And again, if you're going from measurements to congruence, that would be the definition of congruent angles. Okay? So this is actually a pretty important theorem. It is called the congruent complements theorem. So, if 2 angles are complementary to 1 angle, those angles both have to be the same. All right? So, let me know if you have any questions on the congruent complements theorem. Otherwise, you're going to try some practice now. So, you will either need a sheet of paper because your notes does not give you a ton of room to write, or if you can write small, go you. But I highly suggest getting a sheet of paper out for this. I want you to try A. I want you to rearrange them, put them in order. If you want to rewrite them, go for it. And then part B wants you to write a full, complete proof all by your own. And it's actually very similar to the one we just did. It says if 2 angles are supplementary to the same angle, then those 2 angles are congruent. So if you are lost on part B, I want you to go back and look at this proof, and it is almost the exact same proof. Instead of complementary, you're dealing with supplementary. Okay? So, very, very similar proof. Okay? One says complementary, one says supplementary. All right. Press pause, try A and B, and we'll go over the answers. Press pause. So, number 1, go ahead and start with your given. So, it said 1 and 2 are vertical angles. 2, we know they are congruent if they are vertical angles, and that reasoning is vertical angles are congruent. You could have also said vertical angle theorem. They put their given third. Again, you can have these flip-flopped. It's up to you. So you could have had them flip-flopped. As long as you had this one first and this one last, then you're totally good. But that was the transitive property again, because 1 was 2 and 1 was 3, so 2 has to be equal to 3. The trickier one was probably part B, but again, it is the exact same proof that is on the next page, except you are changing the word complementary to supplementary and the 90s to 180s. Okay? So if R and S are supplementary to T, I know R plus T is 180 and S plus T is 180 based on definition of supplementary. Then they did the transitive property or substitution property, if you put that here, because they were both equal to 180. Then I knew they were both equal to each other. Okay, so put red on the right, blue on the left. Now that's kind of hard to see here, but going from 3 to 4, your T's disappear. They were subtracted, so subtraction property of equality. And then the only thing that happened from 5 to 4, maybe you messed that up or didn't write enough steps, but get rid of your M's, make your equal congruent. Okay? All right. Let me know if you have questions on the congruent supplements theorem or the congruent complements theorem, two probably important theorems moving forward. Otherwise, you have one more thing to do on your own. So I want you to try, last but not least, 1, 2, and 3. 1 wants you to talk about congruent complements theorem. 2 wants you to list types of information that can be listed in a geometric proof. And then 3, he made a mistake. See if you can find it. Okay? And then we'll be done and we'll wrap it up. So press pause and try those on your own. Time. All right. So on the first one, the congruent complements theorem. So if D and F are supplementary to J, then I know that D and F have to be the same. And so that's what I wanted for number 1. Number 2, what kind of information can you list as reasons? So reasons go on the right-hand side. So it was looking for properties, postulates, definitions, given stuff, and anything that we have proven in the past. Okay? And then number 3, Kenneth made a mistake. What did he do wrong? So he should have switched reason 2 and reason 3. So let's see. The reasons for statements 2 and 3 do not make logical sense based on the proof. Okay? So I would first need to know that it is an angle bisector before I know they are congruent. So that was probably pretty tricky to see. So you need to know it's a bisector, and then the reason it went from congruent to the M's was definition of congruent angles. So you just needed to flip-flop number 2 and number 3 on the reasons. Okay? It's totally fine that this given was way down here. If you wanted to put it first, you can, but that doesn't mean he's wrong in the way that he did that. Okay? All right. So that is 2 column proofs. Again, this takes practice, and so we're going to keep practicing, and then we'll get better at it, okay? And we'll do it all year. Yay. Thanks for watching. Let me know if you have any questions.